Good afternoon, good morning. I want to thank you all for joining us today for this online seminar. Before I pass this off to our presenters, I do want to cover just a few housekeeping items. In the control panel, there is a section titled Handouts. There you will find a PDF copy of this presentation that is available for download. There is also a product brochure, disinfection measuring system, so feel free to download that as well. And then, of course, if you guys have questions throughout this presentation, feel free to drop those questions in the chat box. We will be answering questions throughout the presentation and also at the very end. So with that being said, I'm going to go ahead and pass this off to our presenters, Thomas Chirdo and Steve Smith.
All right. Hi, everyone. I'm Thomas Chirdo. I'm the Analytical Product Business Manager for our West Coast operations. And Steve, you want to go ahead and introduce yourself?
Yeah, and I'm Steve Smith. I'm the National Product Marketing Manager for Liquid Analysis for Endress Hauser USA.
All right, so we just kind of wanted to thank everybody for joining the presentation. We're going to be going over our free and total chlorine analysis systems that we have. And for this first portion, I'm going to go ahead and turn it over to Steve.
Thank you, Thomas. So the presentation today, we're talking about optimizing chlorine measurement, and we're doing that by talking about systems that are designed to measure free and total chlorine. So first I want to talk a little bit about chlorine and about disinfection and why it's important and how it's relevant. So when we talk about disinfection, we're really talking about having safe drinking water. If someone says, well, why do we need to be adding chlorine or any other disinfector to the water? It's because us as consumers want clean drinking water. We want clear, clean, tasteful water for our personal use. When we talk about clean, we're talking about water that's both optically clean. We want clear looking water, but more importantly, we want water that's pathologically clean. We don't want germs or bacteria in the water that could basically make us sick. Therefore, we use disinfection in order to clean the water and make sure it's free of bacteria and other organisms. The most common disinfector used in industry today is chlorine. And we ask ourselves why? Well, because chlorine has a tendency to be a very effective disinfector, for one, and it also has residual effects, so that as you add chlorine to water and that water travels through the water system, that chlorine will continue to disinfect as the water moves through the system, so that by the time it hits your home or your company, that water's adequately disinfected all the way down the water stream. We talk generally about disinfection at drinking water plants, but the same also is relevant in process operations, wastewater effluent. When wastewater treatment plants are dispensing wastewater out of the facility or effluent into the aquifer, they as well need to understand what the chlorine levels are and disinfection levels are, so that the water that they're discharging is safe to be able to put out into the aquifer. Next slide, Thomas. So a few facts about chlorine. Chlorine is really used by the vast majority of operations or water plants in the US. Virtually 98% of all water utilities in the US are using chlorine for disinfection. Chlorine is expensive. You have to be able to control it in order that you don't waste money or over chlorinate. Too little chlorine and not enough contact time, you've got a health risk. You aren't destroying the bacteria enough, so you've got to make sure you're putting adequate amounts of chlorine into the water system. We certainly don't want to be putting chlorine in and finding out we're not putting in enough, because then we just haven't succeeded in making that water safe to consume. Too much chlorine, number one, is a waste of money. Number two is it can cause objectionable odors. It can cause off tastes in those who are consuming it. So we don't want too little, we don't want too much. Too much chlorine also can lead to cancer-causing combination chlorines like trihalomethanes, haloacetic acids. So again, you don't want to have too much chlorine going into the water. You want just enough to know that you're effectively disinfecting that water. Now, some forms of chlorine, and we'll talk about the different forms of chlorine here in a moment, but some are more effective in disinfection than others. And there's also this pH effect that we need to take into account when we're doing, for instance, an amperometric chlorine measurement. So we've got to keep in mind that just because we say chlorine doesn't mean that that chlorine is an effective disinfector. We need to understand what type of chlorine it is and under what conditions that chlorine is being dosed into the water. Next slide, Thomas. So we're going to talk about free and total chlorine in this presentation. Free chlorine primarily is measured in drinking water operations, in some wastewater and utility industries. If you think about it, from what I just said before, you want to put in chlorine and ensure that you actually have a residual of free chlorine left over after you've dosed and the majority of your organisms have been destroyed. So you're going to find free chlorine applications, most commonly in drinking water applications, where they're going to be looking for trace measurements of free chlorine. You're going to be finding it in process applications, where they're looking just to do overall pathogenic kill. There's being used typically at higher concentrations. You'll also find it in food plants, where they're washing vegetables or conveying materials using water. They're going to want to run disinfection on that water in order to make sure that water's clean, that they're moving the vegetables or the fruits around in the facility, and those are going to be at higher concentrations of chlorine. And then additionally, obviously, in swimming pools. We all know that swimming pools are generally disinfected with chlorine, and so they're looking for trace levels and monitoring levels of trace chlorine in our swimming pools that we use. Next slide, Thomas. So let's talk about the different forms of chlorine. And I like to use this illustration as a way to describe the difference between what we call free chlorine, combined chlorine, and total chlorine. And oftentimes someone will say, I want to make a chlorine measurement. Well, you really need to differentiate between whether that measurement is a free chlorine measurement or generally a total chlorine measurement. So when we talk about chlorine, it's going to be present one of those three forms generally. And it's the free chlorine that really does the hard work of killing bacteria and oxidizing the contaminants in the water. So when you take chlorine in whatever form, liquid, solid, even gaseous form, and you add it to water, initially all of that chlorine is present in that water in the form of free chlorine. So you see here in my example, we've taken our cylinder of water, we've dumped some free chlorine into that water, maybe it was sodium hypochlorite, and all of the chlorine now in that water is free chlorine. Now what's going to happen is that chlorine is going to begin to combine with the contaminants that are in the water, the bacteria and the organisms, and it becomes what we refer to as combined chlorine. One example of that is chloramines. That's when ammonia combines with chlorine, you get chloramines. So combined chlorine is still a disinfector. It will disinfect just like free chlorine will, although it doesn't have the strong oxidizing capability that free chlorine does. So while your combined chlorine will do some disinfecting, it's still that free chlorine that's present in the water that's doing all the majority of the heavy lifting and the sanitation. So you always want to remember that you always want some residual free chlorine left over after you've dumped your chlorine or dosed your chlorine into your water, and that chlorine's combined. When everything is basically come to, let's say, equilibrium, you still want some free chlorine left over, because that ensures that you've added enough chlorine to totally disinfect the water, but had a little bit left over. And in a water plant, when you're sending that water downstream, that residual free chlorine is continually disinfecting anything that might be on that pipeline going all the way to the consumer on the other end. when I take my free chlorine and my combined chlorine together and look at what I have, that's total chlorine. It's the sum of both the combined chlorine and the free chlorine that's in the water. And total chlorine is more commonly measured in wastewater treatment plants because they are actually interested in understanding how much total chlorine are they sending out into the aquifer so that they're not dispensing too much chlorine into that aquifer. So again, what you're measuring really depends on, do I want to measure free chlorine or do I want to measure total chlorine? And that's really going to depend on your application. So again, the application for free chlorine is most commonly found in municipal drinking water plants where they're disinfecting the water near the end of the process so that that water that's leaving the drinking water plant is free of bacteria and organisms that can harm us. But they want to make sure as that water is being dispensed and delivered downstream that there is some residual free chlorine left. So that's why we need systems that can measure free chlorine at low levels as it's leaving the drinking water plant. You'll also find this in a few industrial applications as well. So next slide, Thomas. But in addition to free chlorine, that's not the only thing that these drinking water plants are trying to measure. They're also interested in measuring things like pH. Want to know what the pH of the water is. They're also interested in measuring conductivity because that gives us a sense of how much dissolved solids might be in the water. They may also be interested in nitrate, nitrite, as well as iron analysis to be able to look at the overall quality of the water. So when we talk about drinking water plant analysis or analytical measurements, this free chlorine measurement is not the only measurement that they're interested in these types of installations. So we're talking about drinking water plants. There is a whole array of measurements that they're going to be interested in. In addition, one I didn't mention is turbidity as well. I mentioned that earlier, that we all want nice clear water coming to our facilities and homes. Next slide, Thomas. So one of the questions we most commonly get from people when we talk about residual or free residual chlorine measurement is it an approved method? Does the EPA accept an amperometric measurement, which is what we're going to be talking about here today, as a methodology to measure free residual chlorine in water? And the EPA method that we're referring to is method 334.0. And method 334 was rewritten a number of years ago after submittal to the EPA, showing that an amperometric free chlorine measurement system is just as accurate, just as reliable, and can provide that same quality measurement as a colorimetric or DPD test can. So therefore, if you look in method 334, even in the first paragraph under its scope and application, you'll see here highlighted, it says this method allows the use of any type of online chlorine analyzer, i.e. amperometric, DPD, etc., for compliance monitoring when used in conjunction with a grab sample reference method approved for drinking water compliance monitoring. So those of you as users out there who are wanting to turn to amperometric methods, you can rest assured that it's accepted, EPA accepted method under 334, as long as you have a methodology in place to be able to verify the instrument in that application. And that's an easy thing to do with a handheld DPD test method and being able to sample water off of your analysis system. So next slide, Thomas. So as I said, EPA method will allow for the use of either amperometric or colorimetric methods of analysis. And each analysis method has their pluses and minuses. One of the reasons that amperometric measurement is becoming so popular, primarily, number one reason is it's reagent free. Colorimetric or DPD methodologies require the use of chemicals or reagents. They have to be mixed with the sample and will produce a color. And that color is measured and correlated back to the chlorine concentration. Well, with an amperometric sensor system, you use no reagents. It's a direct sensor measurement of the chlorine level. So the maintenance levels of the system go down. You get a faster response time. you have less measurement error. So there's a whole range of benefits that Amperometric technology is bringing to the marketplace over colorimetric measurement. Colorimetric measurement has been out there for years. It has been the standard method for measuring free and total chlorine for many operations. But today, we now have systems that can measure that doing it amperometrically and can provide a much lower cost of ownership over the long term of the instrument. Next slide, Thomas. So what are some of the issues with DPD or colorimetric analysis? As I said, number one, those types of systems will require reagents, potentially buffer solutions to standardize that analysis to a given pH. What a lot of people don't realize is that when you run a DPD test, a colorimetric analysis for free chlorine, that those colorimetric analyses are being done and standardized with buffer to a specific pH, because the chlorine concentration, i.e. the hypochlorous acid, which is really fundamentally the chemical disinfector that you create when you add chlorine to water, is pH dependent. And so what people don't often realize is these DPD tests are buffered. They're controlled to a given pH. And so therefore, you're going to find out here in a moment that when we talk about our amperometric systems, those systems as well require pH compensation, so that we're comparing apples to apples. If a DPD test, which you're using to standardize and calibrate your system, is buffered and controlled to a given pH, then my amperometric measurement should also be measured and controlled and standardized to a given pH. So that's why you're going to find out here that pH is also a critical measurement within one of these free chlorine systems, and that's to be able to compare apples to apples and get a true chlorine measurement under a standard pH value. These DPD systems, because they're moving reagents and chemicals around and sample, have moving parts and pumps and tubing. They're using a cuvette and a colorimetric optical sensor to be able to make that measurement. So you have to worry about the cleanliness and the maintenance of that optical cuvette. And then you can also have all sorts of unintended consequences like stray light, contamination, other things, cross sensitivities that can have an effect on the performance of the device. So again, that's why many customers now are starting to move away from DPD measurements and selecting the amperometric approach because it eliminates a number of these potential issues with DPD. I think at this point that sums up my portion of the presentation. I think I'm going to turn this back over to Leslie right now, and we'll see if there are any intermediate questions here before Thomas's takes over and really gets into the details about our amperometric systems.
We do have one question, Steve. I have someone just wanting to find out what other available methods to disinfect as per slide, the third bullet, or per slide 3, bullet point 1.
There's primarily, chlorine is the most common. Chlorine is the most common method of disinfecting. Now, you can use chlorine in different forms, as I said. You can get it in liquid form, you can get it in solid form. We're starting to see more use of chlorine dioxide, which is chlorine in a gaseous form. It used to be historically chlorine dioxide was much more problematic. It was more difficult to implement it in a process. But now chlorine dioxide's more readily available and has some benefits over chlorine itself. So you will see some people using chlorine dioxide. Another way to disinfect is ozone. Ozone will disinfect, but it's not generally used at large levels in drinking water. It's used more commonly in some of the life science applications where they're trying to disinfect their systems. The other way you can disinfect water is using UV light. But again, in a drinking water plant, it would require a rather large bank of UV lights in order to adequately disinfect the water, so you don't commonly see that. You will see some UV banks of light used to disinfection in wastewater treatment plants, but not as commonly. So usually chlorine, and now chlorine dioxide, ozone, and UV are the most common methods for disinfecting water.
Okay. So that was one question that we had come in. So Thomas, I will go ahead and pass this off to you.
All right. Thank you, Leslie, and thank you, Steve. So Steve went over a lot of the differences between the Amperometric and the colorimetric versions of how to get your chlorine measurement. Here at Endress Hauser, we have an Amperometric system that we use. And I know there's a lot of information on this slide. What I really want you to take away from it is we do have a digital free chlorine sensor that's Amperometric based. And we have it in 3 versions. A a trace version from 0 to 5 milligrams, the standard, which is 0 to 20, and then the high version, which is 0 to 200. Most of the time in drinking water plants, you're going to find that they want the trace level. They want to get down as low as they can with their chlorine reading. And then this also talks about the response time of our probe. It's less than 25 seconds. I know we had a slide earlier. Some colorimetric systems will take 1 to 5, and there's even versions that take 12 minutes to give you a response time back on the probe. So if you guys have any questions on this, we can always get you more of the technical data of it. I just kind of wanted to give you an overview of our free chlorine sensor. Now, moving on to what is our solution in terms of giving you an Amperometric system to be able to read your chlorine levels. So what we have is our free chlorine analysis system. This is a turnkey product that is built, shipped out to you, and ready to go. Literally, the only thing you have to do is connect the sensor to the flow block and to the transmitter, and then plug this thing into power. So how this works is we use our Liquiline transmitters with our Memosens digital sensors, and then we can give you an Amperometric free chlorine reading with real-time pH adjustments as this goes on. And if you see here, kind of in the bottom right, that's our DPD test valve. So where we mentioned that the EPA approval is dependent on getting a DPD value for it, we can do that right from our panel also. So we offer technically 6 versions of this panel. We have 3 different versions that, depending on what your chlorine range is. So we can do the low, the mid, or the high range. And then I'll touch on just a second the difference between the 2 transmitters that I have listed here. And then also it comes with a pH probe. So you can get that real-time pH dependent chlorine signal. So we have, like I said, we have 2 different versions of this. The version with our CM442 transmitter, what that allows us to do is have 2 sensors in there. So you've got your pH and your chlorine probe. And then we can have 2 analog outputs with a HART output on there also. And then there is 1 DIO board in there for a flow switch input. In a second, I'll touch on what some of the requirements are for the flow on there and why we have that switch on there. And then with this version of the panel and the transmitter, we don't have any additional room for other sensors or IO capabilities, but we'll address that in just a couple of slides. So as you see here, you'll see this word a lot, turnkey. That is because, as I stated, you can literally take this out of the box, connect the sensors up, plug it into power, and hook your water lines to it, and you're up and reading right away. So you'll see here there's half-inch inlet and outlet connections. We put isolation valves on there so you can isolate this from your entire process and just put it on like a bypass line to where you're not having to tap into any of your main lines and worry about having to turn off your system if you have to do something as simple as change out a probe on here. So you can isolate this from your process, change out probes if need be, and continue running. We do on this panel and these probes, we have it controlled to a 15 psi pressure on there. And if you can see, we do have a pressure valve and we also have a pressure regulator on it. And this one is going to come with the transmitter, the free chlorine probe, and the pH probe with it. And then our CCA250, that's our flow assembly that both of the probes go into. And it also includes a proximity switch. So if you go below pressure or below flow rate, our system will actually alarm and let you know, hey, we're running dry or we're running at a low flow, and then you can go in and make adjustments as need be. The next version we have is with our CM444 transmitter. What this allows us to do, it's still going to have 2 sensor inputs, and it's going to have the 2 analog outputs with HART. In addition to that, we can also have Ethernet IP as a standard option on this panel. What we're seeing more and more throughout the industry is a lot of the industry is moving towards Ethernet IP. It just makes it a lot easier to commission and start up instrumentation, and you can get a lot more data off of the transmitter and off of the sensors with Ethernet IP. And then it still does include the extra board in there for the flow switch input. The nice thing about our CM444 transmitter is it's expandable, meaning if we were to open that up, there's going to be a few empty slots in there, and that allows us to add in additional sensors to it. Let's say you want to get a conductivity reading or a turbidity reading. We can run that through this same transmitter without you having to buy multiple transmitters for multiple measuring points. And then if you have other digital communications that you need, Modbus, Profibus, DP, Profinet, we have the ability to modify the transmitter to include those with it also. And this is just kind of showing it's going to have all the same things that the CM444 transmitter version had. It's the same panel, same flow cell, everything like that. We're just giving you a larger transmitter to be able to have additional sensor inputs, or even something like a relay. If you would like this to help with some control on it also, we can put that into this transmitter. And this is just kind of showing an installation point that we have out in the field. You can see the inlet, the pressure regulator as it's going through, our flow block that has the chlorine and pH probe built into it, the DPD test port, and then our outlet. And then again, along with our CM44 transmitter, just depending on which version of it that you would need. So second, the other one that Steve talked about was total chlorine, where the customer needs to know all the chlorine that they have in the water, not strictly just the free chlorine that's giving them the fighting power, I guess I could say, to go after things. So with this one, again, we can get you the technical information if need be. I just wanted to point out it goes from a 0.1 to a 10 milligrams per liter of total chlorine. You cannot run this in a chlorine-free environment. It's not meant to show you the absence of chlorine with this probe. And then again, this one has a little bit slower response time. We're about 60 seconds, but again, still faster than a lot of the colorimetric, which can take up to 12 minutes to give you a return signal back on it. This will look very familiar. The thing with our total chlorine sensor, and I have a picture of one of our panels in a few slides, is you only need the total chlorine sensor. You do not need the pH probe with it. With our CM442 transmitter, you're still going to have two sensor inputs programmed into the transmitter. So technically, with just an extra cable and a sensor, you could have a second measurement point. Whether that's another total chlorine measurement point, you want to measure conductivity or turbidity somewhere in your system, we can do that with this version. Again, all the same specs for the panel, which in that Turnkey Solutions Disinfection System PDF you guys have, the product flyer, will also have a lot of this information on there. We kept it simple. We use the same panel, the same flow block that we do with our free chlorine sensors. It's just that you do not need the pH probe with this one. Again, if we move to the CM444 version of the transmitter, you have additional slots where we can add sensors to it or different digital communications. And again, with the CM444 version of this transmitter, we can get you Ethernet IP as a standard for us. If you do need to add additional sensors or a different digital communications, we can still do that. We just take a little bit of time to modify the transmitter before we ship this out to you. Again, you'll see that word turnkey. Everything here, it's the same specs as the free chlorine panel. Just know that a lot of these, we do have a lot of our chlorine panels, we do keep stocked at our Greenwood, at our North American headquarters in Greenwood, Indiana. So normally, on a normal order, we can get them out fairly quickly, but if all 83 of you who are registered right now and attending decide to order these chlorine panels, we may have to extend those delivery times a little bit on there. But by all means, please order all the panels. We would love that if you did it. And then you can see here, so this is our total chlorine panel. Again, we just have the single chlorine probe in there. That's all you need for it. This one, they ended up just doing, soft lines into it. They didn't hard plumb it in. And then you just see how simple it is. You literally just need to plug it into power, and then you're up and running with it. So we try to make this as easy as possible for you as the end user to be able to connect it, plug it in, and get it up and running and get those readings for you. Now, a lot of sites won't just be measuring chlorine in one point in their plant. They'll be measuring chlorine at multiple points throughout their plant, or they'll need to take backup measurements with it. And so we came up with a solution. Instead of you having to continuously buy the entire panel and transmitter and everything, we have this chlorine expansion panel. And if you see, it looks just like the bottom half of our full chlorine panel, except it does not have the sensors in it, and it doesn't have the transmitter. So what we do with this is you can get a chlorine expansion panel. All you need is the sensors for it. And with our CM444 transmitter version, or even our CM448 transmitter version, we can connect up multiple chlorine panels to one transmitter for you. So that saves you guys on time, maintenance issues. It saves on cost, because now instead of, let's say, 4 panels worth of transmitters, you only need 1 transmitter with it. And so if you ever have any questions on these, our inside sales teams and our rep teams know how to order these and know what pieces we'll need with it, which literally is just going to be the sensors, the cables, and possibly an extra sensor card in our transmitters for it. And again, speaking of Turnkey, this is how the system will arrive to you. It's already pre-built, ready to go. The sensors are in the box. They're just not plugged into the transmitter and wired in because shipping. We don't want them to get knocked around or messed up. And these sensors you have to keep them wetted. So if we were to put them in that flow block, they could go dry, and we don't want that to happen. So all you really need to do with this is mount this to the wall, plug in the sensors, plug in your water supply and your power, and you're good to go. Everything's already pre-wired, so all you have to do is it's a little bayonet lock for our probes to connect to our cables, and you're off and running with it. All right, I'll show you this. This is in that product flyer that we have, but it's just to show all the different versions we have. So we have a trace, a standard, and a high-range free chlorine probe with our CM442 transmitters, our CM444 transmitters, and then we also have a version with Ethernet IP. And then for total chlorine, there's just one probe for that. So we have the 442, the 444 transmitter, and an Ethernet IP version, along with our expansion panel. So this is just the information. This is in that product flyer. So if you ever have questions on it, you can reach out to us, our inside team, our rep firms, and they'll be able to get you the correct panel that you need and sensor that you need for your application. So in summary, the free chlorine panels and total chlorine panels that we offer here at Endress Hauser are ready to install. They're a reagentless system using the Amperometric free and total chlorine probe, which again saves you on a lot of time and money. You're not having to buy reagents every single month to run your chlorine panels. You just every few months, maybe even as long as a year, you may have to replace the electrolyte that's in the sensor or the membrane cap itself. It's a low maintenance system with stainless steel flow components. You may have seen other versions that have tubing with them or plastic. We try to make a pretty robust panel that can survive a lot, where you're not having to worry about swapping out tubes and connectors and things like that. The integrated DPD test port makes it really easy for you to do that manual verification and calibration with it. We have a 2-sensor and 4-sensor versions available for our panels, and we can expand them to include most digital communications methods. And we also have that expansion panel in case you just want to add additional chlorine measuring points without having to buy multiple transmitters for it. So Leslie, that's pretty much everything that I have on this. I wonder if you could join back in and let us know if there are any questions out there for Steve or myself to answer.
We actually had a good handful of questions, so I'm going to go ahead and start giving these to you so we can I'll try to get through most of these questions in the time that we have left. So the first question I have, what are the benefits of liquid chlorine versus chlorine, or benefits of liquid chlorine versus chlorine gas?
I guess I'll answer that one. Liquid chlorine has always been just a simpler material to use than chlorine gas. Chlorine gas, you have to be careful, obviously. You have to plumb your gas lines in and get your system set up to be able to deliver that chlorine gas properly. Liquid chlorine or granular chlorine is actually a little bit easier to add to a process and use. So there's some advantages from that standpoint. Chlorine dioxide, you have to be a little careful about how you store it because it can be, chlorine will burn, it's explosive. So you have to be careful with it from that perspective. But there are some benefits with chlorine dioxide over liquid chlorine that are causing more and more companies to look at chlorine dioxide as an alternative. Used to be that you had to generate chlorine dioxide on site with a chlorine dioxide generator, and now there's more simplified ways of getting it. We do offer a chlorine dioxide probe, which we haven't talked about in this presentation, but we do have the ability to measure chlorine dioxide as well as free or total chlorine with an Amperometric sensor technology as well.
Thank you for answering that question. The next question we have is, what voltage does the control panel need? If it's 120 volts or greater, is it third-party listed?
I mean, we offer 120 volts and a 24 volt DC. Steve, I believe all the panels are the 120 volt AC option, if I'm correct.
That's correct. Yep.
The next question we have, does the output of the system need to go to sewer or a tight tank, or can it go back into the process?
That's an excellent question. Generally speaking, if you're talking about drinking water, there's an approval called NSF approval, National Sanitation Foundation. Generally speaking, if an instrument or a measurement point is measuring your water and you want to put that water back into the process, generally speaking, all the devices or materials that come into contact with that water have to have NSF approval. Unfortunately, given the nature of these devices and the components, this device does not have NSF approval, which means the water coming off of this cannot really go back into a drinking water supply. Now, if it's wastewater and you're sending it out to the aquifer, that's a different story. That you could put back into the process. But generally speaking, in a drinking water type of operation, the water leaving the system would have to go to drain because it doesn't have NSF approval on the components.
I'm going to go ahead and move to the next question. Thank you for answering that. The next question I have, do the DPD test kits have different pH buffer values? Because the DPD kit we provide has a 6.3 pH value. I think you might have answered that maybe already and said I stand correct. So I'm not sure if that got answered throughout the presentation or not. But do you mind just touching base on that?
Yeah, I mean, Thomas, you want to touch base with that, or you want me to?
I mean, at least I don't know of different pH values for the DPD test kits. I think ours is just kind of set. You know, is it that 6.8 or is it the 7.6? Yeah.
No, it is the pH value that DPD tests are standardized to. Generally speaking, with a buffer, is roughly 6.3, 6.5, somewhere in that general area. So that's kind of the magic pH number. If your pH is lower than that, you can be assured that 100% of the chlorine that you add is going to be in the form of hypochlorous acid and is going to be disinfecting. So generally speaking, DPD tests are buffered to basically a roughly 6.3, 6.5 pH. So that's what you would find in a DPD test. And that's what our system does, is it looks at the actual pH of the water and makes an adjustment on the measurement to reflect what it would be if the water was at a pH of 6.3, which is what a DPD test does. You can imagine that the pH doesn't go any lower than that, because we certainly don't want drinking water that's real acidic. So generally speaking, that's why the pH is done to that level, to get it right around neutral, or a little bit less than neutral, because that's kind of if I showed you the curve of pH versus acid concentration, hypochlorous acid concentration, you would see that it's right around that 6.3, 6.5 value, where the curve flattens out at pretty much 100% hypochlorous acid. So it's ideally where you want to operate.
Thank you. I'm going to go ahead and move to the next question. What if I already have a Liquiline XMTR with enough spare channels to accommodate the Memosens instrumentation? Can I purchase the system without the XMTR?
XM. Oh, I think they're just saying transmitter.
Okay.
Yeah, I mean,
sorry about that.
If your transmitter, yeah, if your transmitter already has, let's say on a free chlorine panel, you need 2 sensors. So if your transmitter already has 2 open channels on it, you could buy just the expansion panel and the pH and free chlorine probe and 2 cables and connect it to your existing transmitter. If it's a total chlorine probe that you need, or total chlorine reading, then you just need 1 channel open on your transmitter. So the answer is yes, you would just go the expansion panel route with that one.
Okay, thank you. The next question, is there a sensor to measure chloride content of the stream?
Chloride content. In reality, I'm not sure I understand the question, but let me try and answer it anyway. In essence, what a free chlorine sensor is doing is it's actually not measuring chlorine or chloride. What it's actually measuring is hypochlorous acid, which is what you form when you pour chlorine or add chlorine to water. And it's the hypochlorous acid that's a disinfector. Now, there are ion selective sensors that we have that are used as part of a different sensor technology that we have in wastewater that actually do measure chloride ion, but that sensor is really only used in a particular type of application in wastewater. So I would have to say that there is no specific sensor that we have that is focused on just being a chloride probe.
Thank you. The next question I have, this attendee said, I noticed on slide 21 that the installation has a sample inlet, maybe they meant outlet, in the sun. Does the temperature of the sample affect the reading? Will the reading fluctuate depending on the seasons, example, winter and
summer? No, I mean, the pH probe has a temperature sensor in it, but I don't know if I've ever run into that at all, Steve. Yeah.
Oh, yeah.
Yeah. And again, these panels, we have customers who put them, they put them outdoors, if they want to put a sun shield over them, or they put them inside of a cabinet, that's perfectly fine. Like I said, the only electronics you really have is just the 120 volt power going to it. So, these are not meant to go in, let's say, waterproof boxes or hazardous classification areas. But if you're worried about that, if you're putting this outside in Phoenix or up in North Dakota where it's going to be cold, 350 days a year, you could always put it inside a box or, put it indoors and keep it kind of at a steady temperature there also.
I'm not sure what this particular person is trying to ask. Maybe is there an installation reference list for the total chlorine system used in wastewater plants? I think is what they're asking.
Yeah, we could probably be able to get a reference list put together. We just have to, with something like that, we have to get written approval from the customers first before we can release some of that information. But in a generic sense, we could always look and tell you how many we've sold into wastewater plants. But as for specific references, if you want someone you could call and speak to, we would just have to get approval from that end user first.
Okay. Thank you. And then next question, is there a UL approved version?
No, we use CSA to do our approvals on these systems. Or I should say, let me correct myself. We use CSA as our nationally recognized lab to do approvals on our devices. So while our sensors and our transmitters do have the option to be sold with an approval, these systems were actually built with just general purpose transmitters. Now, if someone were to insist that the transmitter have, I should say they have a general purpose approval. If someone said, I want my transmitter or my chlorine systems to be a class 1 Div 2 version of approval, that could probably be done, but it wouldn't be one of the standard panels. But I would question why that would be necessary. So that's one question you have to ask yourself. Secondly, if you're just looking for an approval, yes, these have a CSA CUS general purpose approval on them. So they do have an approval, it's just not a UL. We elected not to use UL as our approval agency. There are various, what they call nationally recognized labs. They're called NERDLs, nationally recognized labs that do approvals. And generally as a vendor, you pick one and that's who you work with, and we work with CSA.
There's still a good handful of questions, so I'm going to keep plugging around along here. The next question I have, any issues with cell plugging with particles for total applications in wastewater? Considered using a filter before sample cell.
Yeah, I would always recommend to have a filter in there. It's kind of hard to tell without being able to really see the flow block, but the way it's designed, the flow block actually has a channel where it points the flow directly at the sensor, at the head of the sensor. So yeah, it's a pretty small channel that's in there. So yeah, there would be no issue with putting the filter in there. I guess maybe the only issue is if the filter slows down the flow too much, but I don't think I've ever seen that have being an issue. So.
Okay, thank you. Let's go ahead and go to the next question. Why don't we need the pH probe for total chlorine applications?
That's a good question. Because total chlorine is not pH dependent like free chlorine is. As I mentioned before, when you're measuring free chlorine, what you're actually measuring is hypochlorous acid concentration. Again, when you add chlorine, free chlorine to water, that's what you're actually forming, that is the disinfector, hypochlorous acid. The balance of hypochlorous acid to what the other direction it can go to is what's called hypochlorite ion. And in water, the balance of those two is affected by pH. So that's why you need pH measurement to know whether you're leaning towards the hypochlorous acid direction versus the hypochlorite ion direction. Total chlorine, it's not the case. In total chlorine, you're measuring everything. So there is no need for pH compensation because you're not measuring just hypochlorous acid, you're measuring everything. So you don't need pH compensation to do that. So that's why you don't need a pH probe in total chlorine measurement.
I think you answered this question already. This person asked, is the control panel UL listed? I think we covered that. They did follow up with a question, is the control panel CSA US listed or just CSA?
It's CSA CUS, so it's both Canadian and US approval with CSA.
Thank you. The next question I have, do you have a solution for high pressure application, need system suitable for 150 PSIG or protected up to 150 PSIG?
No, so with these systems, the chlorine measurement is done with a membrane and an electrolyte solution, and that 15 PSI that we have on there, that's pretty much right about where we have the pressure for the membrane. What can happen is if the pressure goes too high, it can tear that membrane, and then you're getting your water directly into that probe and losing the electrolyte on there. So we would have to be able to reduce the pressure down to that 15 PSI to be able to get a true reading on it and not damage the probe.
Okay, I think we have maybe 2 more questions unless others come in after this. Do you have a portable version for chlorine residual sampling in the distribution system?
No, I mean, you would still need to use the transmitter. Steve, I don't know how much. Well, I'm just going to say no for now, I guess, is what I'll go with.
Okay. And then this looks like it's going to be the last question. Groundwater supplier 1 is making chloramines. Supplier 2 gets water from supplier 1. Supplier 2 needs to boost the chlorine before sending out. Should supplier 2 measure free or total before boost?
Can you repeat the question again? I want to make sure I
can.
I was going to say, I'm
okay,
flashing back to like college exam questions going, what?
Okay, I'll read it again.
Go ahead.
Okay. Groundwater supplier 1 is making chloramines. Supplier 2 gets water from supplier 1. Supplier 2 needs to boost the chlorine before sending out. Should supplier 2 measure free or total before boost?
Yeah, it's an interesting question. Let me try and describe what I think is happening. The front end supplier, or supplier 1 in this example, has evidently the water they're dealing with, or the water they're sending to the next point in the process, or supplier 2, has had chlorine added to it. That chlorine has combined with ammonia that's in the water or other materials, and it has formed chloramines. Now, as I said before, chloramines are an example of combined chlorine. Now, if supplier 1 has only put enough chlorine in that they've basically just created a whole bunch of just combined chlorine in the form of chloramines, that's what supplier 2 appears to be getting. Now, if supplier 2, what you have to ask yourself is, what is supplier 2 interested in? Are they interested in knowing what the total chlorine is of that water? Or are they wanting to take that water and make sure that it's adequately been chlorinated for disinfection, in which case they would want to know, they would actually probably want to add more chlorine to it till they got to a point where they actually had some free chlorine, not just chloramines, but they have some free chlorine. And at that point, they might want to measure free chlorine, or maybe they want to measure total. It depends on what they need to be measuring going out of their process. So to me, the question to ask is supplier 2 measuring some discharge, and that's where they want to measure a chlorine measurement? And at that point, do they want to measure just free, or do they want to measure total? It's sort of at what point in the process are they measuring, and what are they trying to understand at that point in the process? Now, I will say, having said all that, that chloramines actually do have some disinfecting capability. It is not unusual nowadays to find wastewater treatment plants that are using and trying to measure chloramines as a way to understand whether they're adequately disinfecting their water going out. It's interesting that when you create combined chlorine, there are chloramines, there's dichloramines, there's trichloramines, and there's a lot of discussion in the literature nowadays about how much disinfecting can you get off of monochloramine versus dichloramine versus trichloramine. And so that's a whole new area kind of understanding what people are trying to do and why they're trying to do it. But in that example, it's hard to say. It just depends on what is supplier 2 trying to measure, where are they trying to measure it, or what do they want to measure and where are they trying to measure it, as to whether they should be doing free or total in their process.
That was our last question. I do want to thank all of our attendees that came this afternoon, this morning. Thank you for joining us. And I also want to thank our presenters for giving this online seminar. So with that being said, I want to wish you all the rest of your day. And of course, enjoy your weekend as well. Thank you. Bye.
Thanks, everyone.
Thank you.